This conference will now be recorded.
Today we will be discussing like a overview of our embedded system and like what we are going to study in our whole course and like what are the projects we are covering, right? So we'll be discussing in detail what we are going to do in our entire course. So before starting, I want to understand like what you know about embedded system. I mean, like when I say that embedded system or like any even IoT system or whatever it may be, so what you think about it? I mean, what is the meaning of embedded system? Let's say that somebody says that like I want to build an embedded system or embedded engineer, for instance, like what he basically does. What is the main component of embedded system? So I want this session to be interactive. I mean, as usual, like all the sessions will be like kind of interactive sessions. So more than I speak, you have to speak here. So what is the meaning of embedded system? What do you mean by embedded system? Jagan? You are all like first time you are studying embedded system? I mean, you are working professionals or you are freshers? Please be interactive. Am I audible? I'm audible, right?
Yes, sir, you're audible.
Yeah. So what do you mean by embedded system?
It is a system that's made up of some components to do some specific task. Specific task.
Right, right. It's actually a system which does a specific task and which has a computing element in it, right? So, like when I say computing element, it can be a microprocessor, microcontroller, right? I mean, nowadays, like even we have a FPGA, right? So, this alone forms a embedded system. What else will be there? We will have various peripherals, right? So, we may have some kind of memory to store the data, right? We have memory, we have sensors, we have actuators. Any other components you remember? Like what other components we can have? We will have various power systems, right? Right? What else we will have? So we will also have some kind of transceivers or interfaces, right? Interfaces, transceivers to transmit, like maybe like if I want to transmit the data wirelessly, we will have various transceivers, right? So this together forms an embedded system, right? This is based on the application as well. I mean, it is like based on the application. Let's say like I want to build a, moisture detecting device, right? So then this sensor may change, right? So basically like with this particular basic components, we'll be playing with various permutations and combination as an embedded system, right? So when I say sensors, can you name certain names of sensors? Like what are the different sensors we have? Like, do you remember any of the sensor? Can you name some
LDR,
sensors?
IR, LDR, IR, touch sensor,
Yes.
flame sensor.
Yes. Moisture sensor, rain sensor, right? Strain sensor, stress sensor, lot, right? So in terms of actuators, motors, right? You'll have various pneumatic devices, even like output. If you want to see the output, you may have to connect some display, right? So in case of memories, what are the different memories you have?
RAM, ROM, FROM.
RAM, ROM, SSD, flash, right? So in terms of interfaces, what do we have? We'll have USB, right? Ethernet. Any other interface do you remember?
UART, are you talking about that?
UART, SPI, right? I2C.
Hmm.
In terms of microcontrollers or microprocessor, like we have various vendors. You can see the MSP series, 8051 series, STM series, right? You have various architectures as well, like ARM architectures. Now we talk about RISC-V architectures, right? So now I have these embedded systems and I want to perform certain operations, right? I mean, like, let's say that like I want to read a sensor data and I want to push into cloud, or I want to build a simple display system, right? So this microcontroller alone can perform these tasks. Only with the microcontroller can I perform these tasks? No, right? I need to have various programming techniques, right? So what are the ways I program this ideally, this microcontroller or microprocessor? How do I program? Or like whatever the various
Mm.
programming languages I can use.
Using IDE environments like Python and all the other languages, embedded C.
Yes, first of all, we have two classification here. One is bare metal and another is operating system based, right? In case of bare metal, I can program directly using certain languages like Python, embedded C, C++, right? And in terms of OS operating system, Linux, FreeRTOS, various operating systems we have, right? So now coming to our course structure, we usually like follow bottom-up approach. What we do initially, we start discussing about various languages. We start with various language models. Let me present my screen. So if you see, we start with the very fundamental aspects of programming. Okay. So with the practical C, we start with the very basic concept of C. Then we go with object oriented concepts like that is C++, followed by this is the basic C languages like bare metal approach. Given a microcontroller, if you want to program a microcontroller, right? So ideally, I mean, if the application is very small, right? So then there is no need of going for C++, right? And no need of going for kind of operating system, because operating system is like set of already existing stacks, right? I mean, you are very small. Let's say you are having like you are building one small timer. So then going for the operating system is unnecessary overload, right? So you are unnecessarily consuming a lot of power, right? Unnecessarily consuming a lot of memory. So we have to like, based on depending on application, we have to decide whether we have to go for a bare metal or operating system. So initially, in order to understand, like if you want to develop an application for the operating system also, first thing you have to understand is the basic bare metal language concepts. So that is where we start discussing about bare metal concepts. We start with C, C++, and some basics of Python, like how we can run a embedded system with Python. Like you know that like Tony MicroPython is one of the things like what we will be using. So I'll be demonstrating various hardware-based programming also with the Tony MicroPython. We can use Raspberry Pi Pico as a platform for that particular approach. So initially, we will be using like abstract level of learning. I mean, we may not in detail. We may learn like what is like this MicroPython does with respect to that processor and all. But we will be like mostly focusing in terms of languages rather than like architecture in the initial few sessions. So once that is done, we start discussing about Linux. Okay, Linux and RTOS. So we actually, like as I mentioned, so we'll be following bottom-up approach. So we start with bare metal, then we start operating system. Okay, so in terms of flow, if you want. So we start here, then we start operating system. Here we take Raspberry Pi as a platform. We start discussing about how we can actually implement various Linux application on the Raspberry Pi. We run various programs there. We develop various applications. We develop various projects there. Especially for the Linux, we will be using Raspberry Pi as a platform. Then, for the RTOS purpose, we will be using STM-based microprocessor. So, if you see the flow, actually, like initially we start with the Linux. Then, in order to go to the STM, right? So, we will not directly go to the RTOS. So, we start discussing on microprocessor. Okay. So here where we get deep into the architectural part. So here we start understanding like what is the ARM processor architecture, what is the RISC-V processor architecture, right? So in terms of like how we can optimize in terms of power, how we can optimize in terms of memory code, I mean like memory, how much memory consumption it does, like memory mapping, memory architecture, right? So when I say like I'm understanding the architecture, we actually go in detail, basically three architectures. One is 8051, another is ARM, and third one is STM architecture. So in order to understand any of the microcontroller, right? Understanding like first we have to understand a basic 8-bit microcontroller. That is where like we start understanding 8051. You might have already studied in your BTech, but here we will go a little deeper and we will try to correlate some practical aspects of industry, right? So I have been working in this industry from like almost 11 plus years. So whatever my industry experience in terms of architecting these things, right? Like if you want to design your own system, let's say like you want to build your own sensor-based like agricultural product, or if you want to build your own automotive product, let's say EV product. So we start discussing how we can build with these tools. So embedded system is a tool, right? So using that, we can build any of the automated system. So this is a differentiating factor, right? I mean, like we talk about AI is taking out all the jobs, but the niche skills like embedded system design skill. So when I say embedded system design skill, it doesn't mean that like you have to study only the software, right? So it is a combination of hardware and software. So that is where we will be studying here embedded system as a whole. Like, I mean, here we will be discussing about hardware concepts also. Here we are discussing about software concepts also in detail. So it's a fusion of hardware and software. Okay. So here, in terms of microcontroller architecture, we go in detail about various architectural aspects, and then we extend that knowledge to the ARM processor. And STM32 is one of the extension of the ARM processor, right? I mean, it is like using ARM processor, they have built STM32 microcontrollers, and STM32 series processors also are there. So we have STM32 boards in our campus. So you can use, we will be using that hardware. I mean, like whatever the project we do, we will be doing it in that hardware, and we will be experimenting all the projects. So we have a provision to buy also. You can actually like buy this STM32 at like very nominal costs as well. So if you want to practice this in your home, right? So I mean, like it comes like very small nominal prices. So you can buy that as well, STM32 boards. So where you can actually experiment all the projects or systems what you build in the lab, right? Uh, like once we study about that, then actually like we come back to like this is a microcontroller or microprocessor concepts, right? So we understand in detail whatever the architectural aspects are there, whatever the functional aspects are there, we study in detail. Once we study in detail, we start like in that process itself, we discuss about sensors, interfaces, these concepts, right? These concepts we especially discuss during STM32 discussions. Okay. Here we have like we will be having detailed discussion about like how we can interface various sensors, what are the aspects, and we'll be discussing in detail like how we can interface using USB, Ethernet, UART, SPI, right? In detail we'll be discussing. Also, then like during ARM architecture discussion, we'll be discussing about various memory aspects, right? What is the RAM, what is the ROM, how we can actually program, how we can actually control the DDR, what is the significance of DDR, right? So then we will be coming to the display aspects, actuator aspects, right? So finally, once that is done, we will come back to the RTOS aspect of the microprocessor. So now we have learned like at this stage, right? You have learned like how to program a microcontroller. You have understood like the architecture of the microcontroller. You have understood what are all the fundamental tools required to program the microcontroller. We have understood the Linux aspects also. Now we will see, like once this STM32 architecture is understood, we will see how we can actually run a RTOS. Like now we talk about running a machine learning algorithm, AML model on the microprocessor, microcontroller. So we will be start discussing about how we can actually run a small microcontroller model on the artificial intelligence model on the RTOS. So we will be having very detailed discussion on this. We will be running small microcontroller. We will take a like agricultural project. So maybe we'll fetch real-time data. So I mean, personally, we have one actually one small startup where we are working on this embedded based agrotech products. So we have deployed various nodes, agricultural node in the field. So I'll demonstrate like how we can actually fetch the data in the real time from the agro node, how we can do certain analytics, right? So I mean, like predicting irrigation aspects, how we can actually predict when to irrigate the water, like various challenges, right? So we will be discussing in detail. So once that is done, now let's say you know that like now all the systems are up and running. Now the data, these are all like in the end node, right? So I mean, like whatever the processing I discussed or whatever the data I have processed, these are at the end node. We don't have access to it. I mean, nowadays, like people talk about IoT. IoT, do you think IoT and embedded systems are different? What is the difference between IoT and embedded system? Is it different? So embedded system and IoT, it's like, I mean, it's basically of embedded system, right? So ideally, if you see embedded system added with some connectivity, that cloud connectivity, right? So it forms a IoT systems, right? So basically, what we'll be doing, like next aspect, like whatever the processing you have done, whatever the data you have acquired on this embedded system, we have to push that into cloud, right? I mean, like nowadays, like embedded system alone doesn't serve anything, right? So I was mentioning like we have these agricultural nodes deployed across in Karnataka. So these data we have to keep fetching in the real time. We have to have like various concepts of programming. I mean, various concepts of acquiring this data to the cloud, right? So that is where we will be discussing about networking concepts. So we will be discussing in detail this TCP/IP applications, how you can actually fetch this data to the cloud, how you can actually program this data like from the cloud. Let's say like if I want to control an irrigation from the cloud, I have to give the command, right? So how you can actually do that? So there are various protocols also, like for instance MQTT, right? Also, we have something called socket programming, right? So I mean, if you want to actually, like you might have seen that cloud-based CC cameras, right? So it is basically like streaming applications, right? So through WebSockets. So we'll be discussing that simple application, how you can build your own embedded systems using that kind of techniques, right? So far, any questions here in this flow? Any questions?
How about the real-time scenarios and what currently ongoing in this field in embedded? Like if I'll go for an interview and I'm searching for any particular role in this area, then how this will
Right.
help? This course will help.
Right. So actually, like if you see, I mean, the entire flow, what we are discussing, right? So that is like, if you see here, whatever we said. So this is the general flow, what we follow in the industry as well. Like, let's say, like I'm building a system. So whole flow of this course will be like an industry project. I mean, as a personally, like as I mentioned, like from like 11 plus years, I'm working on this field itself. So we'll be discussing in a way how we actually right now we are working in the industry as well, right? So let's say that like I mean when I say I'm discussing on like building this socket programming, how actually like if you want to build a IoT system with the socket programming, what are the process we follow, what are the tools that we follow, right? So we'll be discussing in that flow. So that is where it will help you. I mean and in terms of projects also, that I haven't come at actually. So in terms of projects also, whatever we are building, that is as per the industry. So I mean like initially we will be building very small projects, but that once we actually reach this stage, right? When we start discussing about ARM processes and all, we start building a projects which will be useful for the industry. Like we will be actually building certain real-time ADAS models, right? I mean you're getting the real-time data fetching and processing these image processing techniques. So these kind of projects which will be building, that will really help you in terms of interviews as well, right? So if you see in generally what happens in our BTech, right? BTech or in your masters. So we'll be studying each subject, what are the subjects we saw here. So that we will be studying in a discrete manner, right? So we'll be not relating anything. I mean, you will be having one C++ subjects, we one C coding or another Python. So all these discrete subjects will be there, and you will not be many times you will not appreciate the significance of these subjects. But here, as I was showing you, so the flow what we go, right? So this flow will be relating with how we can actually whatever the things we are studying, how it is actually applicable for a system we are building, right? So each thing we have to relate to the systems what we are building, right? So that is where it will help you to easily crack your interviews, right? So that is the one thing what will be what is I mean the flow what we are following, the approach what we are actually following here, which will really help you to get into industry.
Okay, thanks. And
And
one more thing,
in
this
terms of yeah, in terms of interfaces also, as I was mentioning, so many a times they were developing a
yes,
drivers, let's say for developing a drivers for USB, Ethernet. These are the advanced concepts, right? So this knowledge, I mean, if possible, I'll just little bit touch on how you can actually develop drivers for PCIs and all. So that will keep you updated with the industry standard, right? So that is where USB 3.0 driver development, uh, in terms of BSP generations, right? Developing BSP packages and all. So that will keep you updated with respect to industry standards.
currently, what are the processors and controllers being used in industry right now? Latest.
Right. I mean, see, actually, this what I was mentioning. So we will be discussing we start with the 8051. That is because uh, if I directly start ARM A9 processor, people will not be able to appreciate. That is the quite advanced processor, right? So we start with the 8051 to understand the basic concepts. But STM32, whatever I mentioned, that is right now used in across in an industry for your automotive purpose, right? And ARM processor as well. So whatever we discuss, I'll try to discuss with respect to ARM A9 application processor. I mean, how you can actually program to that, use various applications. And we have in the institute a Z board. The Z board is actually a SoC which has FPGA as well as A9 application processor. So that is where actually so here one advantage is I'm an embedded engineer with a FPGA experience, right? So nowadays if you see FPGA alone, the processor alone people will not use, so they will be using FPGA along with that. So we will be discussing those concepts also, I mean how we can actually have a hybrid design, accelerator based designs and all. So now if you see in the industry there is a lot talk about having an accelerator at the outside and interfacing it to it, developing your own accelerating using some kind of RTL languages and all, right? So we'll be discussing that concepts as well. Hope I answered your question.
Yes.
Others, any queries? So coming to the projects, so these projects, whatever we will be doing, that is like on the go. I mean, like whenever we discuss the concepts, so parallelly we will be like demonstrating these projects, and you'll be understanding. So initially, as I know, and as I said, like we start with the fundamental, right? So we will be starting with the simple LED as it's like kind of hello world of our embedded system, right? So then we start with like some simple digital clock with RTC integration, with like LED screen, OLED screen, LCD screen. I mean, there we have like various permutations and combinations. We'll be discussing that. We will be discussing about temperature and humidity monitoring and pushing into cloud. So these concepts again, actually, we integrate our cloud, the socket programming concept, what we had discussed, right? So uh, then we will be discussing about PWM aspects. Then intermediate level, we start discussing about like UART communication, how you can write various UART drivers yourself, right? Then you know that like nowadays, like a data logger is one of the thing, uh, which is like frequently used in like major application, right? I mean, whenever you say that like any IoT application, whatever the application I was mentioned, the nodes deployed across. So in such applications also we need this kind of systems, and how we can actually implement a data logger, writing to the memory, storing it, or pushing into the cloud. So those things also we'll be discussing. We'll be discussing about like I2C uh, peripheral interfaces, right? So we have capacitive touchscreen interfaces, ADC interfaces. Coming to the advanced projects like motor control, wireless configurations, right? So like how you can actually interface these Bluetooth, Wi-Fi modules, IoT weather stations, right? So smart home automation, robotic arm control. And coming to actually professional level, I mean, somebody was asking that like in terms of industry standard thing. So how we can actually develop your own custom boot ladders, CAN bus application, audio signal processing applications, industrial automation. So as I was mentioning, so basically we are also having startup which deals with like automation and IoT. So we will be having various projects, real-time problems. Let's say like one of the problem what we had recently is in the tails industry. So they have their own machineries where they have actually like frequent motor jamming issues. Like I mean, whenever that through conveyor, the data they feed this soil, right? So these stones get stuck in the conveyor, and because of that, their motor jams. And as you know, like if you are like thorough with the electronic things, so when the motor jams, the current increases and motor burns, right? So that is where like we developed one automotive detection system where it will detect the system, I mean detect the jam, and immediately it turns off the entire system. So also it indicates through cloud. So these kind of systems we have developed. So especially like in Mangalore and like Udupi districts. So there are like a lot of cashew factories. We are actually working closely with these factories, and like we are developing various systems. So I'll be bringing certain problem statements from those things also, so that actually you can work on that real-time projects, right? So and that is one thing what I promise you. Like I mean, you will be getting like during the if you are actually like uh, freshers, you're still looking for the job, right? So where I can give you internship opportunities in my own company, so that like I mean, whatever the projects we are having, right, problem statement along with this course, right, you can learn that, right, on hands-on you can learn, and you can actually get an idea what is going on. So that is one good thing about this thing. I mean, like we will be supporting on that, and post course also, right? Whenever you are in the industry, so like many of my students still, so whenever they face certain issues, so they contact me and they actually get a guidance like how we can resolve these issues and how we can address the things. So one more thing is like last project what we'll be building is like building various models, AI models on the processors or controllers. So we'll be discussing various like, you know, that tiny ML kind of models and all. So how we can run in the real time on the edge processing node. So, and like one of the projects which I haven't included here, so that is actually SATCOM, one of the SATCOM projects what we are like which I am working on for my client. So I'll be giving some insight on that as well. So if you want to build a simple SATCOM based systems and all, right? How you can actually build, you can write certain embedded drivers for that. How you can build SATCOM based IoTs, right? So those things also we'll be discussing as a whole project. Okay. So any questions, any doubts here? So in terms of like, I just want to show you, like, if you are freshers, right? So in terms of opportunities, right? Uh, Coming to any of the industry, for instance, nowadays, right? Let's say your automotive industry, telecommunication industry, or satellite industry, defense industry, right? For that matter, any of the industry right now, there is a need of embedded engineer, right? So there is a huge scope for the system engineers nowadays. One of the reason is like now, if you see the market, the government is lot pushing towards building make in India systems, right? So when I say make in India systems, we need to have engineers who will be building those systems, right? I mean, like, it is not that like just we will be making in India. There is a lot of skill set gap. That is where there is a lot of since we are building this hardware here itself in India itself, so we need to get into a lot of these embedded engineers. So I mean, I can say now the booming things in India. I mean, as you know, like most of the software things are getting done by this AI, right? But here in India right now, the booming thing is like one is VLSI, right? So like people like who does this RTL physical design, they're getting a lot of packages. Another is embedded engineers who will be building these drones, robots, right? So uh, so overall course objective is basically we'll be discussing, as I mentioned. So various aspects of the complete system design we'll be discussing, and we'll be using ARM or STM32, right? So we'll be learning like various language models. So so here, I mean, as a system level, right? We'll be discussing on four concepts. Like one is embedded system, as I was mentioning. So another is IoT, cyber physical system, and physical computing systems. So the combination of these, right? So we'll be discussing basically. Okay. So anyway, this in detail on the fundamental aspect in one of the sessions, right? So whenever we discuss on this aspect, so we will be discussing in detail. So if you have any doubts, you can ask, or else like we can wind up. So if you have any doubts on this, you can discuss with me in terms of course. Any questions? Any doubts?
Hello.
Yes, Megha, tell me.
Yeah, so we'll be focusing on this application development side or device development side or both.
Uh, some concepts on application side also we discuss, application development side as well we discuss. We will be mostly focusing on device driver because that is a complex thing, right? I mean, application side is something like uh, what we'll be discussing, like very basic things like how we can actually develop various on top of the given device driver, how we can develop various applications. That is actually during the projects we'll be discussing mostly on the application side. But initial few discussion mostly focused on the device driver aspect, because once you understand what is happening in the device driver side, right? Like, I mean, in terms of interfaces, in terms of directly communicating with this memory aspects. So if you work on this, so then working on the application side is like very easy, right? So it is kind of combination, you can say, but you can say that like 70% of our discussion mostly on the device driver side, because that is a very complex thing what you have to understand first, right? So then using this device driver development knowledge, building the application on top of that, it is like very easy. So we'll be discussing, you can say, in a nutshell, I can say we'll be discussing on both.
Okay.
Any other questions? Or anything else if you are expecting, you can let us know, so that like we can curate course according to that. So do you have any other requirement that like you want to learn or anything, so we can update our course as per that as well? Like, I mean, if you have any specific requests in terms of course.
So, will tell you my expectations. Actually, totally, I have 10 years of experience, out of which 5 and more, like around 6 years, I have worked in embedded, that too only in application side. So, application development,
Mm-hmm.
audio applications and all. And for this
Mm-hmm.
3 years, I'm working in different domain, rail domain, only UI based and C++ based application development. So,
Mm-hmm.
okay, going into taking this course, my expectation is to revise all the embedded related concepts, and plus
Mm-hmm.
my whatever experience I have in application development and getting into embedded again.
Okay, 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 okay. That will really help you actually. I mean, in terms of those things. I mean, like whatever the projects I was mentioning, right? So if you can focus on those as well, right? I mean, like especially these interfaces and all. If you get there, so hope you have interface experiences and all, right? So you have worked on the interfaces and all.
SPI, yeah, SPI, I2C, UART, that and all I worked, but it's the now I have around 4 years of that. So again, I
Uh-huh.
don't have the hands-on. Yeah.
Yeah, so we will be also discussing certain interfaces like CAN, right? So USB, right? Ethernet. So those things will really add on to whatever the experiences you have, right? So that also we'll be discussing in detail here. So
Okay.
you have worked on bare metal, or you have worked on top of operating
Uh,
systems?
Both bare metal and it was free RTOS also,
Okay.
Linux based also, but it was my task was on application development side.
Okay. Okay.
So can
Others,
we
any
discuss
questions you have?
timings and this e-learn difference of e-learning classroom and the self-paced?
So weekends we will be having sessions. usually like in the morning same time, weekends. So e-learning, you will get the recordings actually. I mean, like like whatever we have discussed here, right? So the same recordings you will get. And also in the e-learning, one thing is like whatever I have discussed and some other professors also like in the previous batches. One of the person from who was actually a very good experience and like I think more than 20 years experience. He also covered various concepts, so all these discussions, right? So we will get in the e-learning portal. Along with that, like whatever we discuss here, that access also you will get. So it is a combination actually. So e-learning and this. So here you will get like, I mean, whatever the doubts you have, for instance, like if you are watching any video and you have doubt there, so we can discuss live in the live sessions, weekend sessions. And you can actually come to campus as well. So we have hardware access, so you can come to campus and get the hardware access as well. So those things also available.
Hardware access, is it possible to get over online VPN?
Pardon?
I'm working in Gujarat. I'm not there in Bangalore. So I was just asking if the hardware access can we get on over VPN?
Yes. That arrangement we can do. So especially our FPGA hardware and all, it is always available in the VPN. So even if you want to do advanced projects like with the FPGA, right? I mean, FPGA as a SoCs. So our Z board is also available in the VPN. So we can give this embedded hardware access through VPN as well. So you can actually program to that and try VPN based hardware. And
Okay.
so the small, these STM boards and all. So I mean, you can check with the institute. We will be providing the nominal cost. I mean, like whatever is available in the market. So we will be giving some subsidized costing. So you can buy that as well. So, because I mean the microcontroller hardware and all, it is of low cost, right? I mean, which comes around like 2 to 3K range. So that anyway, like you might get some subsidized costing, so that you can purchase.
Yes.
Any other questions?
Not from myself.
Okay, then. Thank you. Let's meet in the live sessions maybe from next week. Thank you all. So if any doubts or queries, you can always contact me. You can just ask Institute also. They will give you the contact number of mine. So you can directly call me and clarify the doubts if you have any queries. So you will also get, I mean, those who have just joined. So you will also get recording. I mean, you can just request for the recording, and like if you are really missed any of the in between any of the discussions, right? So you can watch the recordings and understand what we have discussed today. Thank you. Thank you all. Hope we meet again in the live session. Thank you.
Thank you.